QD comma X here. Okay. 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 Right. So we are here. Okay. So delta D star QD comma X. Okay. So what is this? Can we compute this? So what is delta D star of QD comma X? So this is delta D star. So this is in the DFA side, right? So this is in the DFA side. So this is equal to delta D of delta D star of W, and this is this, correct? And so why? And then can you tell me like what is this?
Oh, that is same as the my lemma delta D star and
right?
this WA.
Yeah.
And
so
WA
this
is
delta D of this thing is the epsilon closure of some set P, yeah, where P equal to from P1 to Pk, and let's say, and if we have some Q which are of the form Q1 to Qj, right? And we said, and what did we say? That for all Pi, in capital P, there exists some Q. Let's say this PL Qj belonging to, let's say, I think, let me call this Q only. There exists some Qj belonging to Q such that Qj on A goes to Pi, right? So this was how we defined the delta D, right? And then essentially, so this is by definition of this delta star, right? So this is this essentially gives you this delta star of Q comma W. Okay, so and finally you have that if delta D star, you have QD comma X, since these two things are equal, if this belongs to F of D, this also this, then this implies that delta star Q0 comma X, right? Then this is intersection F is not equal to phi, right? So this is from the definition, the way we define the F of D. Okay, so I mean it's exactly similar to the construction of the equivalent that NFA is equivalent to DFA, but now we have a bit more complicacy here because of the epsilon closure, right? So what we showed is that indeed the DFA that we constructed here, it's equivalent to the epsilon NFA, right? I mean, one could have also constructed instead of a DFA, could have constructed an NFA like this. Any question? Vikram?
No, it's fine.
Okay. Okay. So yeah, there where we had some technical breaches, but okay. So right. So can you do the following? So suppose I have this thing that this is an epsilon NFA, right? So this is an epsilon NFA. Can you tell me how the corresponding DFA should look like? How should the corresponding DFA look like for this epsilon NFA? Can you try to construct the corresponding DFA? How are you going to do this? construct an equivalent DFA. Construct an equivalent DFA. Right? So first we will start with the QD, the initial state of the DFA. So how did we define? It's like QD.
It will be equivalent to Q. The QD will be a set of states called Q0, Q1, Q2.
Like this, right? So what will be my QD? QD is Q0, Q1, Q2. Very good. Right? So this is the epsilon closure of Q0. Then
on reading 0, okay.
Yeah.
On reading 0, I go to the same set of states, Q0, Q1, and Q2.
You go to the same set of states.
Yes.
Okay. So it is Q0, Q1, Q2. That is equal to QD. Right? So you get this.
But on reading on 1, where do we go?
So what about on reading 1, Vikram? Where do you go? On reading 1, where all do you go? Sorry? Huh? Oh, okay. So I should move this. Okay. So what about this? Now reading 1, where do you get? Only Q1? Sorry? You go to Q1, Q2. Okay. So on reading 1, you go to Q1, Q2. Okay. Now, okay. What about, so let's do this a bit and then I think, what about reading 2? Where do we go? Where do you go by reading 2? You go to only Q2 for each of these. So you had now all these states. You have one state which is QD, then you have got this state, and then you can keep on doing this until you reach a fixed point. Like you are not reaching any further states, and you can cross it. So is it clear? Like given an epsilon-NFA, how would you construct the DFA, right? So you read a letter and then you take the epsilon closure of it, right? Okay. So, right. So now, and what we showed is that given an epsilon-NFA, you can translate this into an equivalent DFA. Okay. Right. So we did this. So we looked. So what we have is this theorem. So essentially, a language L is accepted by some epsilon-NFA if and only if it is accepted by some DFA. Clear? Okay. Now, so let me ask you this question. Maybe. So far in the definition of DFA and NFA, right? So far, let's say if I consider the definition of an NFA, for example, so when do we say that a word is accepted? When do we say that a word, right? So suppose you have an NFA A. When do you say that a word W belongs to L of A, right? We say that, how did we define the language? Is like L of A equal to the set of words W such that delta. It can be an epsilon-NFA also. Right? Suppose I say the delta star of Q0, comma W intersection S is not empty. Right? This is how we define the language. Now, suppose I change the definition of the acceptance. Okay, how do I change this? That instead of intersection, this thing I say, I changed it to this. Q0 comma W is a subset of F, right? So this it's a subset of F. So what does it denote? Can you tell me in words, what are we talking about? What does it mean, Ankit? So suppose there is an NFA like this, and delta 0 star Q0 comma W is a subset of it. So what does it mean? Become So the definition of delta star doesn't change. So what does delta star of Q0W give you, first of all? Set of states where you can reach after reading W. And now what does it say when you say that delta star Q0W is a subset of it? Ankit, what does it mean?
I mean, it should be accepted. I mean, the W should be accepted by or should be recognized by language L.
W should be recognized by language L. No, a word is accepted by an automaton.
Yeah,
So the
yeah,
question,
sorry. Yeah, it should be accepted by the automaton.
Right. But you see that the acceptance now, that the way we are defining the language of the automaton has changed. Earlier it was like this,
Yeah,
and now it is like this. So what is the difference? What does it mean to say that?
Yeah, difference. I think difference is there. Is that in the above statement? Okay.
Yes.
I'm 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 considering this. I'm considering all the final states intersecting with this Q naught comma W. But here, Q naught comma W is subset of F. So at least one of not at least or it's very hard. I don't know.
So Vikram, what does it mean to say Q naught comma W, delta star Q naught comma W is a subset of F? What does it mean to say that its intersection F is not equal to 5? There exists some final state, but in terms of NFA, what do you have? Like how do you get some final state? Some path is there, right? There can be multiple paths, and some path reaches an accepting state. And when I'm saying that it's a subset of F, what does it mean? All paths reach an accept. All the paths reach an accepting state. Correct? So you are reading, say you have this Q0, you have several paths, right? You have several paths, right? All of them are labeled with W, right? And what we are saying that this delta star Q0W, it gives the set of paths, the set of states that you reach after reading W, right? So let's say I call this capital P. And now we are saying that P is a subset of S, which means all the states here, they should be final states. Correct? Is it clear? So the definition of the automaton now has changed. The acceptance condition has changed. I'm saying that all the paths, I can do that, right? Very much. I can say that all the paths have to be accepted, right? And this automaton, I call it a universal automaton. I mean, it's universal in the sense, so I'm calling it universal in the sense that along all paths, right? Along all the paths, they have to be accepted. The word has to be accepted. All the corresponding runs are accepting runs, right? Now, my question is that if I define my automaton like this, correct? If I define my automaton like this, what kind of language does it accept? So this is a new definition of automaton I'm giving, right? So with all the things that you have studied, you should be able to answer whether this is more expressive than DFA, NFA, epsilon-NFA. We know that all of them are equivalent, right? They are equally expressive. Now with this, are you going to get something which is less expressive, or is it less expressive? What kind of language? Is the question clear?
Yes, yes.
Is the definition of this automaton clear? Like when I'm changing this thing, and now what we are asking is that, is it the case that this automaton gives you more power, less power, or what is the situation here? What do you think? Right? I mean, with all these things, I mean, it's not that like, I mean, you have to now start thinking about also, right? So we have seen enough constructions and we have seen quite a few like different things. You are doing this by induction and so on and so forth. We are writing these definitions, but now we have to also apply them and to see how things are. So what do you think?
I think one side, like if W is accepted by universal automata, okay, then W is also accepted by my DFA, NFA, or ENFA. But
So what he's saying that if W is accepted by universal automaton, so okay, so you are talking about a particular word. I mean,
yeah, let's say some language accepted by
so
universal
some
automata.
language accepted by some universal automaton. So universal automaton. Then what Ankit is saying that L also accepted by your L also accepted by DFA, NFA, etc. Right? Why is it so? Vikram, why do you think? I mean, is it true, first of all? I mean, is it, what about the other direction? If L is accepted by a DFA or L is accepted by an NFA, let's say, right? Does it imply that there exists a universal automaton accepting L? So yeah, so you were saying, so sorry, can you repeat? So yeah, okay. So Vikram says that the DFA can be indeed thought of, like a DFA can be indeed thought of as can be considered as a universal automaton. Can be considered as an universal automaton. That is true, right? Because you have just one run. And here in the universal automaton, you are talking about all possible runs. So indeed, a DFA can be thought of as an universal automaton. So this direction, and since L is accepted by an NFA, it means that L is also accepted. So this implies that L is also accepted by a DFA, correct? L is accepted by an NFA implies L is accepted by a DFA, and a DFA can be thought of as an universal automaton. Hence, if L is accepted by an NFA, then it is also accepted by a universal automaton. What about the other way around? If L is accepted by a universal automaton, then can you think of constructing a DFA, or it is not possible? How would you try to construct in the first place? How would you like to do? What was the idea behind the construction from translation from NFA to DFA? Right. So subset construction. Can you do a subset construction here in a similar way?
Yes, it's possible. Why not? Because set of states reachable, okay, from, let's say I'm a state at Q, and sets of states reachable from there on reading an input alphabet A. Okay, so I'll take that as the this one single state.
So Ankit is suggesting that you can do a subset construction exactly in the same way, and so you do delta of, let's say, Q comma A as the set of states, right? All the states you can. So it is. So this is like you are talking about. You are considering a DFA. So let's say there is a Q prime. So it is and what you are. So you are doing this thing, and so you would like to take this. So suppose yeah. So from Q to A, if you go in your universal thing to a set of states here in the universal automaton A, then in the DFA you will kind of consider all the possible the union of all these states, right? You'll consider, but then corresponding to these also, like, so initially you will have Q0, right? And then you can have Q0 as the initial state. So I have a universal automaton, right? So I'm not here considering the epsilon, but let's say I have the universal automaton. Here you have the DFA. Here you have the universal automaton, correct? And then you say that now, how are you going to define the delta of some QD here? So the QD is there equal to this, is like it's a set, let's say P prime, such that for all Pi belonging to P prime, there exists some Qj, right, belonging to Qd, and Qj on A goes to Pi, right? So you are doing this, right? So you are trying to define the DFA exactly in a similar form. And then what? Then the final state. So Bikhan, you were talking about final state. So how are you going to define your final states? So suppose the set of final states in your DFA. So let me write the DFA here. Suppose write QD sigma delta D, Q small QD, and FT, right? So how are you going to define my FT? Sorry? Okay, so FD is the set of states, let's say Q, belonging to QD, such that Q is a subset of F. Such that Q is a subset of F. Clear?
Yes. But then, sir, Q is subset of F, sir. Okay. Then, I mean, if Q subset of F, then there could be some final state, okay, in subset construction. which is also included with some other states.
Yeah. So
So
there
in
could be
that,
some final states. So for example, you can have like something like, suppose you can have a state like of this form. So Q1, Q2, some Qj, where let's say Q2, let's say does not belong to F. Suppose something like this, right? So I'm
yes,
saying that this is no longer a final state. It's not a final state.
okay.
Why? Why? Because if on reading a word from Q0, if these are the set of states that you reach, right? Which means that there exists some run, right? Starting from Q0, suppose there's a W, there exists some run which reaches Q2, there exists some run which reaches Q1, etc., etc. There exists some run which reaches Qj, and so on, right? Q1, Q2. Now this does not belong to F, right? Now what does it mean? Is this word W going to be accepted by the universal automaton?
No, no.
Is this word? No, it's not going to be accepted by the universal automaton because Q2 does not belong to it, right? So that's why your FD should be all those states such that in which all the component states from the universal automaton, they belong to it. Correct?
Yes.
Clear? Okay. So indeed, then what do we show? That even if you consider such a thing, which has universal states from which all the runs that you need should be accepted, such an automaton is no more powerful than a DFA. So they also accept the regular languages. Clear? Right? So these are the kind of things you should try to think of. Like, okay, if I do this, if I do that, then how things will change. Clear? Okay, so let me end. I wanted to do more today, but I think it's because of this these technical things we could not. We got a bit late. But let's say I will just finish with this. So we discussed this, right? This is this universal automaton. We discussed this, and now we started our lecture today with the subsequential, right? You have these epsilon transitions, right? We saw that if you add the epsilon transitions, it becomes very easy to get an automaton which will accept the subsequence of L. Given a DFA corresponding to L, right? How do you construct an automaton which will accept subsequence of L, right? With the epsilon transitions. Is it, do you recall this, Ankit? So how to
Yes, yes.
construct this?
Yes,
Okay.
yes.
Yeah. But now, suppose, okay, now I'm giving you another language. Suppose A is a language. Okay. And just look at this. So what is this? So suppose this word A1, A2, A3, A4, A5, etc. This belongs to L. This
Okay.
belongs to L. Now I'm saying that you remove these even letters, the letters which are occurring at the even positions. You are removing them. And I'm defining the corresponding word as, let's say, if this is my W, the corresponding word A1, A3, A5, etc. It's an K, right? So there should be some K. So you will of course have AK if K is odd, otherwise AK minus 1. If K odd, otherwise if K is even, then you have this A1, A3, right? A5 like this. You will be having this. Now I call this word as odd of W, right? Now what is odd of L? Odd of L is like for every word W that belongs to this language L, you consider the odd of W that will be in the odd of L language. Is the definition of the odd of L clear?
Yes, yes.
Okay. So the definition is clear. Now the question is that if L is regular, is odd of L regular? And why am I asking this? Because again, just like this subsequence, if you think in terms of epsilon, then it might be easier to construct such an operator.
No, I'm not able to think about the language L, what kind of construction it should have. But if we make epsilon transition from first to third state, third to five state, something like that.
So
Then,
L is any regular language. So
yeah,
I'm
L
not
is a,
saying that how L, I did not give you any specific definition of L. So what all I
okay.
said is that L is any regular language. Right? And now your intuition is kind of correct, but it's not fully okay. Like, so what Ankit is saying, that you would like to have transitions from the first state to the third state, from third state to the fifth state. But what is the definition of first state to third state? Like, you can have transitions like this, you can go to this, maybe you can go to this, and then you can have a transition like this, and so on and so forth. Right? So what is really a first state, third state? Like, sometimes this state is the first state, then again this becomes the second state, and then this is like the third state, but then again this can also become the second state, and so on. Right? So all I'm saying is that you have to, how would you like to? So we saw similar things, right? I mean, there are, for all these things, you have to like construct something. So we are talking about this construction, and you have to be sort of bit familiar with this construction. The more you practice, the more you look at the languages that we discussed earlier, like the shuffle, perfect shuffle, what kind of things we are doing, and how again we can possibly do something like this. So we are dropping the, so earlier we said in the subsequence, you can drop any letter wherever you want to. You added this epsilon transition. Now I'm saying you are dropping the even numbered letters. And then you remember we did something in the case of perfect shuffle. We considered, yeah, so you had that AI and then the BI. It was kind of alternating. There were two languages in perfect shuffle. Yeah. Correct. So it is very similar, right, in that sense. So what would you do here? If you consider one of the languages, okay, you consider everything. But then if you consider everything, then how are you going to drop these ones, like drop A2, A4? Like, if you consider everything, then everything it can be overlapped. So A1, then followed by, it can be, instead of A2, what you were saying, it can be anything. Is that what you were? Right? So do you remember, Ankit, how we did the perfect shuffle? I mean, did you?
Like,
I think
I was
you were not
not
there,
in,
but it was there in the lecture notes
yeah,
or the
yeah,
handouts
yeah.
that I shared. And
Yes.
yeah, I mean, you can
Okay.
try to work it out.
Okay.
Yeah. Okay, good. So this is what we were doing in the perfect shuffle. If you recall, so we talked about this language A, language B. We talked about a DFA DA, and we talked about a DFA DB. Let's say the states there were QA, and here the states were QB. And then we said we would like to have, uh, oops, we'd like to have states for perfect shuffle of this form, QA cross QB, cross 0, 1, correct? So this was the set that we talked about. So QA cross QB cross 0, 1. This was the set that we talked about for perfect shuffle. Now, Here, you don't have this B. You just have only one language L. Yeah, you are close. So what do you do? Ikhan? So I can keep two copies of the state space. I can keep two copies of the state space. So here, I just suppose I have the state space for L. Suppose I have the state space for L, which I call Q. Okay. And can I keep two copies Q0, 1? One for the even letter, one for the odd letter. And then you switch back exactly the way we were doing with perfect shuffle. Similar, right? And then why am I talking about epsilons? Right? So yeah, so if you are reading, suppose you read so you are starting from the event side, let's say, right? So you are starting from the event side. So Q0, let's say I have 1. And I read, and suppose you have such a transition in the original automaton. On A, you go to Q1. Now I would go to Q1. I would go to Q1, 0, right? And then let's say from Q1 you read a B, you go to Q2. So I'd go read here A, read here B, I would come back to Q2, 0. Now what do I do? Now what do I do? I'm switching from the odd side to the even side. Ankit, what do I do?
On A, can I make transition from Q0 to Q2?
Sorry?
So I'm not able to understand this part actually, to be honest.
The B? Yeah. So let's say I, instead of AB, I call it A1, A2, as I was previously talking about A1, A2. A1 and then A2. Yeah. So what do I do? Huh? Yeah. But what else could I do? For example, in the subsequence, what did we do? We added epsilon transitions. What can I do here? Okay, so think about this. So, okay, so Ankit and Bikram, so this is like a homework. Okay. So this is a homework, and I would want you to turn this into academy. So just write it down. The question is there, right? So this is a homework, and then I think what I want you to do is so essentially this is the question, that this is odd of L, right? And what I would like you to do is to come up with to prove that this language is indeed regular. So to come up with a DFA, okay? And what essentially the ideas that we discussed is from subsequence of L, right? Then we discussed earlier perfect shuffle. Okay, so we discussed all these things, how you construct, and you kind of, if you understand these things well enough, then you should be able to construct a DFA for I mean either a DFA, or it can be anything. Like I would suggest that you can try to construct an epsilon-NFA starting from a epsilon-NFA accepting odd of L starting from a DFA for L. It's not that difficult. I mean, given that we have seen so much of things, right? So the idea is also that now you should be able to apply all these different things, techniques, and try to come up with your own construction to prove things. It's not like that, right? And the more problems you solve, the better you will be in. And there is no hard and fast rule that this is what you have to follow in order to come up with such an automaton. You have to be a bit creative and you have to understand and make yourself familiar, right? Good. So any questions? So if you don't have other questions, so maybe we'll stop here. And so I'm going to put this on Acadly, and you have to turn it in the submission. I think it's not too much of work. I mean, you can just write it on your paper, take a photo, and then submit it. Right? I mean, unless you are not doing these things yourself, I don't think. Yeah, I mean, you will be kind of familiar with the different constructions and the ideas, and some of the exercises you have to do yourself. Right? So I'll just